Unit 8, Day 3 video notes, absolute value and inequalities. Combined inequalities. This is where we have two inequalities, and really the issue here is whether it's and or between the two equalities. And meaning that we are going to be able to satisfy both, or that we have to satisfy both, or meaning that the two inequalities cannot both be satisfied at the same time. And so we're looking for the solution set of one or the solution set of the other, or rather the combination of the two solution sets. Okay, so in this case we have and, which means that we have to be able to satisfy both inequalities. Now let's go ahead and solve each of the inequalities. Okay, so I need to get this x by itself, so I will add 2 to both sides of the inequality, which will give me -1 is less than or equal to x. And of course, I could also flip this around. If -1 is less than or equal to x, then x is greater than or equal to -1. These are two different ways of saying the same thing. Now let's look at the other one. We will add 2 to both sides of the inequality, giving me x is less than, x is less than 4. Okay, so let's go ahead and take a look at what this looks like. So let's look at the one on the left to start with. And being less than or equal to, it does include the -1. So I'm going to use one of these solid dots on -1 to show that the -1 is included, and I'm not quite where I want to be. Let's see if I can fix it. Okay, let's just move the whole line to put it where we want it. I suppose that will work, other than I may have trouble with this. You know what? Let's undo this and fix it a different way. I'm going to just draw it. Okay, so open circle on the -1, and then I'm going which direction here? Well, x is greater than or equal to -1. I'm going to be going that direction. Oh, and it wasn't. It was or equal to, so it's not an open circle. It's a closed circle. Let me fill it in, showing that we're including the -1 in our solution. Okay, now let's look at the other one. X is less than 4. Less than does not include the 4, because there's no or equal to, so that one's open. And now I'm going this way, less than 4. The two of them are going toward each other, and so everything in between, plus, due to my equal sign, the -1, but not the 4, will be included. So let me go ahead and show here that my solution set includes everything in between, as well as the -1. Okay, so we have a special notation that we can use to indicate that it's everything between two numbers. And we write the smallest number, -1, is less than, or in this case, less than or equal to, the variable x is less than 4. And this is read as -1, or sorry, x is between -1 inclusive and 4. The inclusive indicating that -1 is part of the solution set. Okay, let's try another one. Okay, so next example. Let's go ahead and add 1 to both sides. and that gives me 2w is less than 4. And then this one is or. That means that as long as we satisfy one of them, that's okay. And this to me indicates we're probably going to have arrows pointing opposite directions. Let's take a look at it. So let's divide this by 2, giving me w is less than 2. Okay, over here. Oh, I need to get w's all on the same side, so I'm going to subtract w from both sides. And notice I haven't divided by a negative number, so I haven't needed to flip the inequality. So now that'll give me 2w is greater than or equal to 10. Divide both sides by 2, and I get w is greater than or equal to 5. Okay, so let's take a look at this. So we have 2, and we're looking for w is less than 2, so we're going to go that way. And then we have 5, and this one is or equal to, so we're going to fill this circle in. And its w is greater than or equal to 5. We're going that way. Like I said, they're going away from each other. We can't satisfy both at the same time, and that's the reason we're using or here. So what do we have? We have an arrow going that way and an arrow going this way. Again, moving away from each other. The reason that we need the or instead of and. We can't satisfy both at the same time. Okay, absolute value equations. How do I go about solving this? Well, first thing is that my absolute value has to be by itself on its side of the equals sign, which it is. Once I have that, I'm then going to break it apart into two equations, because if we look at it, if we had the absolute value of some variable, well, let's see here. Let's say, here, let me explain it this way. This equals m minus 6 equals 8. Well, m minus 6 might equal 8, and the absolute value of 8 would be 8. Or m minus 6 might equal negative 8, because the absolute value of negative 8 would also be 8. So we have two equations here. We have m minus 6 equals 8, and we have m minus 6 equals negative 8. And now we need to solve each of these two equations to find two answers. So we have let me back up. So we're going to add 6 to both sides. Hopefully all of you caught me making that mistake. So now we have m equals 14. We go over to the other side. Again, we're going to add 6 to both sides. And we have m equals negative 2. Two very different numbers. What do we have here? This really is asking what number is 8 away from from positive 6. Perhaps I won't go into that so I don't confuse you. We're going to break it apart into two equations and solve each of those equations. Moving on now, let's try the same thing with an inequality, and also with something other than the absolute value on the same side of, in this case, the inequality, though it works the same with equations. Let's go ahead and solve this. So first thing we need to do is get the inequality, or the absolute value by itself. So we're going to move the 3 by subtracting 3 from both sides of the inequality, which will give me the absolute value of 2 minus z. Let me fix that so it's easier to read. The absolute value of 2 minus z is greater than 5. Now I'm going to break it apart into two inequalities. And there's just one little trick here that you need to pay attention to. So I have 2 minus z is greater than 5. Nothing new there. And 2 minus z is less than negative 5. Notice that when I use the negative on the other side of the inequality, I had to flip the inequality just like I would if I multiplied or divided by a negative number. And now we just solve the two inequalities. Nothing new there. I'm going to subtract 2 from both sides of the inequality, giving me negative z is greater than 3. And let me make a little room here. Divide both sides by negative 1. And I will have z is less than negative 3. Over on the other side, I will again subtract 2 from both sides of the inequality, giving me negative z is less than negative 7. Divide both sides by negative 1. Let me move this down some more. And when I do, I will get z. I'll have to flip the inequality, is greater than, and now we've got positive 7. Okay, so now I need to graph this. Let me try to put this over about where I want it. Okay, nice enough. So what do I have here? I have z is less than negative 3. So here's my negative 3, and it's not included. And z is less than, I'm going this direction. And then I've got z is greater than 7. So over here at 7, again, it's not included, so it's open. And it's greater than 7, I'm going that direction. So what do I have here? These are going away from each other. I cannot satisfy both at the same time. So in between them, I need to write or. If they were going toward each other, I would be able to satisfy both. And I could write and, or use the between notation, where the smallest number is less than the variable, which is less than the largest number. Okay, now graphing systems of inequalities. Well, the first one, I don't even have to worry about putting into y-intercept form. It's just the variable is less than or equal to a number here. So I'm going to move a line less than or equal to, it's a solid line. And this is x is less than or equal to. So first of all, if it was x is equal to, let's see if I can, okay. And that would give me a vertical line. So first thing is I need to make this thing vertical. And then it's 3. So I need to move it over to 3 there. Okay. So there's my first line. And this says x is less than or equal to 3. Well, that's over on this side, because if you look at the x-axis, over to the left we've got 2 and 1 and 0, and then all the negatives. Those are the ones where the x is less than. So I'm looking at this side of that line. Now let's take a look at the other one. First thing is I need to have it in slope-intercept form. I'm solved for y, but I have one other issue, and that is that my ones are coming before my variables. So I need to move it around. I need to make it y is greater than negative x plus 5, so I can see my slope and my intercept. My slope is a slope of negative 1. And as this is just a less than, not a less than or equal to, I need a dotted line. So let me take this line here, and let me give it a slope of negative 1 if I can. I think I got that about right. And now it's going through positive 5. So let me move it. Whoops, and I'm trying to move the wrong one. Move it up to a positive 5. 1, 2, 3, 4, 5, right there. So now this says y is greater than, so I'm looking for the numbers that are above, because y is greater than as I go up. So I'm looking now for the numbers above this line, like this. So I need to indicate where is the overlap here. And that overlap is this area right here. Notice it's bounded by the two lines. And I'm going to just sort of fill it in. I'm going to make it nice and dark so I can see where my solution set is. Make it real clear here. Okay.